Welcome to Brain Vision.
We need to find the magnitude of the force that is exerted at the rod, and we also need to find the force exerted by the pin at A onto the AB rod. So to start solving this problem, we're going to first find the force that is acting on the rod, and it's labeled here in this free body diagram with a vector that is labeled R. So to start solving for that force, we can say that sum of moments about point A is equal to 0, and we can write that as force R times 1.2 minus the force 60 times 9.5 is equal to 0. And we can take this expression and solve it for the force R. And this will give us a value of R that is equal to 475 pounds. And for part B, we can say that the sum of forces in the x direction is equal to 0. And we can use this value that we just calculated for R to solve for the x component of the force at point A. If we can solve for the y component and the x component of the force exerted at the point A, then that's going to be the force that's also exerted onto the rod AB. So we can then rewrite this as the x component of the force at point A plus R times the sine of 30 is equal to 0. And we can plug in the known terms to get A of x plus 475 times the sine of 30 is equal to 0. In solving this expression for A of x, we'll get a force of negative 237.5 pounds. So we'll now solve for the y component of the force. So we'll say that the sum of forces in the y direction is equal to 0, and we can rewrite this as A of y minus R times the cosine of 30 is equal to 0. This is actually going to be minus 60. Because if we look at the free body diagram, we're going to be subtracting this force that is inputted, this 60-pound force, to be able to keep it in equilibrium. So we do minus 60, and then we plug in the known terms to get A of y minus R times the cosine of 30 minus 60 is equal to 0. And solving this expression for A of y, we'll get a force of 471.36 pounds. So we now know the x component of the force and the y component of the force. So we can now solve for the magnitude of the force at point A. So we can say that the force A is going to be equal to the square root of the x component squared plus the y component squared. And this will give us a force of 527.84 pounds. And we can solve for the direction of this force by saying that the angle theta is equal to the tangent inverse of the y component divided by the x component and this will give us an angle of 63.3 degrees. So the force F is equal, the force A rather, I'll call it A. So the force at the point A is going to be equal to 527.84 pounds, and it's going to be going in the upwards direction at an angle of 63.3 degrees.